Hi there, I'm Hao, and this is just another video of me solving random code problem. So we need to find the median of two sorted array in the log of n plus n, which is the length of the two array, right? So if the two arrays is sorted, right? If you are familiar with merge sort, we can just merge them, right? And then find the middle index. But the problem is we need to do it in log of n plus n, and then merging it would give us a time complexity of n plus n because we need to iterate through every single number, right? So instead, we can run the binary search on each of uh, on both array at the same time and get rid of and try to get rid of half the input, right? Because most of the time when we see the requirement is the log of something is a very big hint that we should use like some variant of binary search. So let's say we have an array 1, 3, 5, 8, 10. So um, let's say it is 1, 3, 5, 8, 10, 32 and 55, 32 and then 55. Right, so this is our first array. And we can call this array A. Right. So we have another array. It's the 2, 4, 6, 9, 10, 9, 9, 10, 44. So this is our B array. So this is our first case, right? Where we have so the length is 2, 4, 6, 7, 2, 4, 6, 2, 4, 6. So 7 plus 6 is 13, right? So we have the length of array A is let's say length of A is 7, length of B is 6, right? So we know the length of AB is 13, right? 13. So even though we cannot merge the array, because it would give us the bad time complexity of O n plus n. But if we know the total length of both the array, right, which we can get in constant time, then we know that the middle index, if the two array are combined, the middle index of the median would be the 7 elements, right, which is index 6, right? So if we have 13 elements, which means we have index from 0 to 12, right? So which means our index would be 6, right? So we get rid of 0 to 5 and then 7 to 12, right? So this is the odd case. We will have an index of 6. So what does it mean? It means that you have to somehow get rid of 6. Um, so at index 6, right, which means it is the 7 element, right? Because our array is the 0 index, so 0, 1, 2, 3, 4, 5, and 6, right? Index 6 means we need to get rid of 6 elements in the front. So we have to somehow get rid of 6 elements in both array A and array B combined. Right. Let's say we can somehow use some kind of binary search to get rid of, let's say, this part, right, which is 3 elements, and this part is 3 elements, right? We're gonna have like some kind of median, something like that. So we know that our K, let's say our K, the K is, let's say K is the index of the target median, right? And we are dealing with the odd length now. For the even length, we need to find two numbers, right? And then add them together and divide it by 2, right? So if we have 1, 2, 3, and 4, the median would be 2 plus 3, right? Divided by 2, which is 2.5. But if we only have 1, 2, 3, and the median would be 2. Okay, so we can have 2 pointer here, A left, right? Let's say A left, and then A right. We can have A B, B left, and then B right. Okay, and then we can find the middle index of both the A and the B element, right? So for the B, it would be this elements right here, right? Because 5 minus 1 divided by 2, right, is 2. Okay. Similarly, 6 minus 0 divided by 2, like plus 0 is 3, uh, which is this elements right here. Then actually, we don't care about the value. We want to look at the index only, right? Because remember, K is the target index of the median, right? So the median would be at index K, right? So let me write it down here. So target, right? Median index, right? So we want to get rid of 6 elements in the front of both the A and the B combined, right? So we can look at the index, right? The middle index of A and B here, which is 3 plus 2 is equal to 5, right? But we want to get rid of 6 elements, right? So here, because 5 is smaller than 6, right? We can get rid of the left half of either A or B, right? Whichever one have a smaller value at the middle index, right? Because we cannot get rid of like the both of them, right? Because if you look here, so the 7 index, right, is 0, 1. The second index is 0, 1, 2, 3, 4, 5, or 6. So the median would be 8, right? The median would be 8, right? So let me go back here. So let me write it down. So the answer here would be 8, right? At the end, we should get 8, right? That's the answer. Okay. Okay. So we want because so now because 5 is smaller than 6, we compare the value at the middle index, right? 6 and 8. And because 6 is smaller, right? So we reset the B left to be middle plus 1, right? So here, right, and we can simply delete this part, right? And we can repeat the same process. So we find the middle index again. A doesn't change, right? So the middle index will be the same. But B, the middle index will be 4, right? So 4 plus 3 is 7, right? And now 7 is greater than 6. It's greater than 6. We want to remove 6 elements, right? From the left because they are already sorted, right? Both array are sorted. So now we can get rid of half of the array on the right. So which one would we choose, A or B? So we would get rid of the second half, the right half of the array that have the larger value at the middle index. So in here, we can see that 10 is greater than 8, right? 8 is smaller than 10. right? So we can get rid of this, right? So it would be BR, BL and BR would be at the same place now, right? We can get rid of the second half. But if you look here, we already get rid of three elements, right, on the left. We already get rid of three elements on the left here, right? And our goal is to get rid of six elements, right? Starting from the left, because the array is sorted, right? To get the median. So let's keep going. Okay, so next we have to calculate the middle index again, right? So which is this one, right? So 3 and 3. So 3 plus 3 is 6, right? Which is not smaller than 6, right? It's greater than or equal to 6. It's not smaller. So we continue to get rid of the second half, right? Of whichever number, so of whichever array that have a larger value at the middle index. So 9 is greater than 8. So we get rid of the second half of B. So we move the BR in here, right? Equal to mid index minus 1. And we have to repeat the process again. And now we have successfully, let me write it again, 2 here. So now we have successfully get rid of 9, right? Okay. So now when we do the search one more time, we realize that BR is less than BL. It is not valid, right? Which means the left and the right pointer overlap, right? Same situation if we have AR is less than AL, right? So in this case, we can just go ahead and return. So if B have no element left, right? B have no element left because BL is smaller than BR is smaller than BL. So B has no elements left, right? So we return A, return the array A here, right? Would at the index K minus BL. So K is 6, right? What is BL? BL is 3. We will have A of 3, right? Which give us 8 here, which is our answer, our correct answer here. So why does it work? It works because it is our target number of elements that we want to remove, right? And why do we need to minus 3? Because remember, we already successfully removed 3 elements from the left here. 3 elements from the left. If BL is at index 3, which means we have already removed 3 elements on the left side. Why not on the right, on the left? Because we want to because the array is sorted, right? We try to get to the median, the middle number, right? Because we already removed 3 elements here, right? So the remaining element that we have to remove is 3. 6 minus 3 is 3, right? We just give it the value at this index. Okay, so in this case, we can solve this problem in the log of m plus n, or a plus b. I don't like m and n, so let's call it a and b. Right, O of log a plus b. Right, right. So yes, it is a general algorithm. The first step is we need to figure out the length, the total length, right? We need to figure out the total length of both array, and then calculate the middle index, right? If the total length is odd, then we can just have 1k, right? We only have one middle element. What is k? K is the target median index. If it is odd, Hello? Okay, yeah, sorry. So yes, if k is if the total length is odd, then we only have one k, one median. But if the total length is even, then we're gonna have two k, right? K1 and K2. K1 and K2, right? We need to search two times instead of one time. The first time we search. So let's say we have let's slow down a little bit here, right? Delete this. Okay, so let's say we have another element here, 66, right? Which means our length now is 14, right? Our length now is 14, 14, right? So our index, right? If we have 14 element, the index is 0 to 13. So our middle index would be k is 6, right? And k is 7, right? 6 and 7, I think. So let's see, 13, 14 divided by 2 is 7, right? And 14 minus 1 divided by 2 is 6. Yeah, so 6 and 7. Yep, 6 and 7. So we need to search two times, right? The first time, we want to eliminate 6 elements, right? To get to the median, the first median. And the second time, we want to get rid of 7 elements to get to the second median, right? And then we can add them together and divide it by 2, right? And yes, that is our algorithm. So let's go ahead and code this up. Let me clear here so we have a little bit more space. All right. So let's rename this. I don't like num1 and num2. Let's call this A and then B. B. So we can have length of A is equal to A length, right? Length of B equal to B dot length, and we need to the total length, right? So length AB equal to length A plus length B, right? And then if length AB mod 2 equal to 0, right? Which mean what? Which mean we are in the second case, which means we have two median number, right? Two middle number, right? And then if we don't, then we only have one, right? So let's create a helper method on search. On search, right? We can take in the A left, right? A right, B left, B right, and the K, remember? Okay. Okay. So we can pass in A left is 0, right? A right is the last index, right? So which is the length of A minus 1. B left is 0, B right is the length of B minus 1. And what is K? K would be the math of floor of length AB divided by 2, right? Okay. So similarly here, the only difference is that we need 2. So plus, right? And then divided by 2 at the end. Okay. So here we have to do a little bit difference here. Our K will be different, right? The first K is the same, but the second K will be length AB minus 1, right? Divided by 2. Okay. So that is our two case. So if we have A left, right, is greater than A right. When A left is greater than A right, which means the left and the right pointer overlap, right? Which means we don't have anything left in the A array. So we return the B array, right? The B array. So the median must be in the B array, right? And then we need to, because we already remove a left elements in the A array, right? So the elements that we need to, the remaining element that we need to remove would be k minus a left, right? Because a left is the number, the total number of elements from the left side that we had removed from array A, right? And we do the opposite for B. So this is B. When B left is greater than B right, which means there's nothing left in B. So we return, so we know that the median is in array A, right? And we have returned B left element from the left side of array B. So we have to return the remaining elements, right, from array A and just return the median. Okay, so that is our 2-base case. And then we need to find the middle index of both array A and array B. So it would be A left plus B A right minus A left divided by 2. So we need to floor that, right? So math or floor, right? Math the floor A right minus A left divided by 2 plus A left. Same thing for B. It is B. Okay. And then we can return, right? Calling our recursive function. So what do we have to do now? We need to get rid of half of the array, right? So if the sum, right? If if the middle index A mid plus B mid is less than K, right? Okay. So if A mid plus B mid, which is what is A mid plus B mid, which is the total number we have to remove, right? Is less than K because we want to remove K elements, right? But if A mid plus B mid is less than K, then we want to remove the second half of the array, of whichever array have a smaller element at the middle index. So if A mid is less than B mid, then we want to remove the first half, right, the left half of A. So let me just copy this. We have the same parameters. Okay. Okay. So we need to remove the first half, the left half of A, right? So we set A left equal to A mid, right, plus 1. And otherwise, we want to return B, the left half of B. So B left become B mid plus 1. Same thing here. Okay, same thing here. So if the total number we want to remove is larger than or equal to K, which means we want to remove the second half, right? Of whichever, we want to remove the right half of whichever array have a larger number at the middle end. So if A is larger, right, we want to remove A, remove the second half of A. So A right become A mid minus 1. And otherwise, we will remove B. So B left at the same, but B right become B mid minus 1. So A mid plus 1. Showing the left half. Now here we remove the second half, the left half of B, right? So the left equal to mid plus 1. Here we want to remove the right half, so A mid minus 1. A right become A mid minus 1. Want to remove the right half of B, So B right equal to B mid minus 1. Okay. And here we need to compare the value, right? Not index. So we need to look at A and then B. A at A mid index, B at B mid index. Right. Right. So every time we traverse, we would cut down the array in half, right? Either array in half. Okay. So it is accepted. And thank you for watching.